This topic is solving literal equations. Now what that means is that your equations have multiple variables. You're used to isolating variables. For example, in this first example, if I want to solve this for x, I have to isolate the x by using our properties of equality. So I will add 5 to each side. I'm getting rid of, or isolate, no, I don't want to say getting rid of. I'm isolating the 2x, so I do need to move the 5 to the other side. So that gives me 2x equals 18, and then divide by 2. You know how to do this. And you get 9. So what we did was we got the x by itself. Well, look at the next one. In ax minus b equals c, the a represents 2, the b represents 5. I'm going to do the same steps. Here I added 5 to each side. Remember, I'm trying to isolate that x. Well, let me put that in a different color. I want to isolate the x. So I'm going to add b to each side. Now, c and b, they're not like terms, so we're going to bring them down as c plus b, or b plus c. The order doesn't matter there. On this side, that eliminated those b's, and I have ax. So just like in the previous problem where I added 5 to each side, now I'm adding b to each side. Now, coming back to the previous problem, you'll see that we divided each side by 2. Well, in this problem, the 2 is being substituted by an a. So I'm going to divide each side by a. So whenever you're solving a literal equation, you end up with a bunch of variables in your answer. So this is your answer. So I have c plus b divided by a. Okay, identify the similarities and differences between the two equations. Well, something they have in common is both of those use your opposite operations to isolate. In other words, those are your properties of equality. Properties of equality. And a difference, the literal equation doesn't simplify nicely due to multiple variables. Again, literal just means more than one variable. The literal equations do not simplify as nicely due to multiple variables. Okay, so let's try a few. Now, when I'm giving you these, I need to tell you which variable to solve for. So you'll see on the right-hand side of each box, it tells you which one to solve for. So here in the first one, a equals L times W, I want to solve for W. Well, right now, there's being an L is being multiplied by the W. The inverse operation for multiplication is division. So I'll divide each side by L, and I have A divided by L equals W. Now the W is alone, and you're finished. You take a minute to try number 2. Okay, make sure you pause this so you can try number 2, and when you're finished, then start it back. You're solving for H, so you're going to divide, the B is being multiplied by the H. I want the H by itself, so I'm dividing each side by B. So A over B equals H. Okay? How'd you do? Excellent. Okay, moving right along. Number 3 and 4 are very similar to 1 and 2. I'm going to do number 4, and then you're going to pause it and do number 3 on your own. All right, number 4. It says to solve for T. Well, it's I equals P R T. That means P times R times T. So I have two things being multiplied by T. So I'm going to take both of those and divide that product. So I have I divided by PR equals T. Okay, pause me and try number 3. Okay, now you're back. On number 3, you want to solve for t, so you should have divided each side by r, and you have d over r equals t. Did you get that right? I'm sure you did. Okay, I'm going to look at number 6. On number 6, you are solving it for r. Now, there's a little bit more going on with this one. I have a equals pi r squared. Does anyone recognize this formula? It's the formula for the area of a circle. Even if you didn't know that, we can still work the problem. First thing I want to do is get r by itself, then I'll take care of that exponent. So I'm going to divide each side by pi. And I have a over pi equals r squared. The inverse operation for a exponent, in this case squaring, is the square root. Squaring and square root are inverse operations. So when you get here, what you need to do is take the square root of each side. The square root of any number squared, or in this case a variable, is itself. I'll tell you more about that in a minute. And here, this is going to stay under that square root sign, and I have the square root of a over pi equals r. All right, let me talk about that squaring a square root. I know that you know that the square root of 49 is equal to 7. And you know the square root, remember the square root, that means what number times itself gives us 49. The square root of 64 would be 8. All right, if I take a number and I have the square root of it and I square it. Oh, wait, I want to move that square to the inside. Okay, this means I'm going to square the 8, which is 64, and then the square root of 64 is 8. You see how it cancels out the square root sign and the squaring, and you just get 8? If I have the square root of 5 squared, that would be the square root of 25, which is 5. Again, you see how the square root and the squaring canceled each other out. So that's the same thing with this one with the r squared. Okay, I'm going to do number 8, and then I'll give you a chance to do 5 and 7. It says to solve for m. Well, the m is being divided by v in number 8. The m is being divided by v. So I need to multiply each side by v. I'm rewriting it because I didn't have room to show that v. All right, what that does, remember, this is the same as v over 1. And when you're canceling, you can cancel tops and bottom. And that gives me v times d equals m. Okay, you take a minute and do 5 and 7. Remember to pause this, do them, and then start it back. Okay, on number 5, you wanted h by itself. H is being multiplied by L and W, so I'm going to divide each side by the product of L and W. And I have V over LW equals H. On number 7, it says to solve for C. Well, what's being done to C is that S is being subtracted. So I'm going to add S to each side. M and S are not common, are not like terms. So I have M plus S equals C. Okay, let's turn to the back. All of those were one-step equations. These are two-step equations, or multiple-step equations. All right, look at the helpful hints. Think backwards. So you're going to go backwards with your please excuse my dear Aunt Sally. You'll start with the subtraction, addition, and so forth, going backwards. Remove fractions by multiplying by the reciprocal. And your last step is usually to divide by whatever is next to your variable. All right, the first one I have A equals 1/2 B times H. It has a fraction. This step right here says to remove fractions, multiply by the reciprocal. So the reciprocal of 1/2 is 2. So I'm going to multiply each side by 2. And remember, that's the same as 2 over 1. Remember the top and bottom rule. Bottom and top cancels when you're multiplying. Because I'm multiplying all these, I can do that. It doesn't matter that they're not beside each other, because we have the commutative property that allows us to move them around. So now I have 2A equals BH. Now I need the H by itself. They're being multiplied together, so I'll divide each side by B. And I have 2A over B is equal to H. Done. Number 10, you try it. Pause me. Bring me back when you're ready. Okay, you should have multiplied each side by 3. And again, if you want to put the 1 underneath that 3, you may. Top and bottom, cancel. And I have 3v equals capital B H. I should have pointed this out earlier. If they use a capital letter, you use a capital letter. Don't change them to lowercase. You have to use the same variables that they used. And we're going to divide each side by capital B. So I end up with 3v divided by capital B equals H. Okay, I'm going to do 11, and then I'll give you a chance to do 12. Number 11, again, I see a variable. There's a 2 in that denominator. So this would actually be 1/2, because the 2 is in the denominator, so that's 1 over 2. My reciprocal is 2, so I'm going to multiply each side by 2. You remember when you were solving one-step equations, and if it was divided, then you multiplied. That's what we're doing here. Those 2's cancel. And I have 2k equals, aha, we've got another one of those squared variables. But we're not looking for that one. I'm looking for m. So I'm going to divide each side by v squared. So this does not require me to take the square root because I'm getting m by itself. And there we go. All right, try 12 and put me back on when you're done. 12 is a little different than 11. You still have the fraction, but it's a variable, d. So I'm going to multiply each side by d. Again, this is top, bottom, they cancel. And I have dA, or AD, it doesn't matter there, equals b plus c. Now to get the b by itself, as it's asking me to do, I need to solve or subtract c from each side. These are not like variables, so I have dA minus c equals b. That's a c. I know it looks like an e, but that's a c. All right, perimeter. Your next one, that's the formula for the perimeter of a rectangle. P is equal to 2 times L plus 2 times W. What we're doing here is I want to solve it for W. So I'm going to start by subtracting. I need to first isolate the 2W, then I'll isolate the W. So I'm going to subtract the 2L from each side. And I have P minus 2L equals 2W. Okay, is the W by itself? No, there's a 2 being multiplied. So now I need to divide each side by 2. And I have P minus 2L divided by 2 equals W. Do not try to cancel these 2's right here. They cannot cancel. If you do that, you're going to get the problem wrong because this is not just 2. This is P minus 2 times L. So you can't just you can't break through this subtraction sign right here. So you're going to leave it. P minus 2L over L. Earlier I said you could subtract, you could cancel because you were canceling through multiplication. That is not the case on number 13. All right, you try 14. Bring me back when you're ready. Okay, to get the by term by itself, I'm first going to subtract ax from each side. I have by equals c minus ax. Or you could have said ax, negative ax plus c. Now, the b is being multiplied by the y. I need the y alone, so I'm going to divide every term by b. Now, notice in the last problem, I just did it with one step, and here I did it with 2. I wanted you to see that it does not matter which way you do it. So here I have y equals c over b minus ax over b. Now, if you wanted to do it like I did 13, from this step, you would have had by equals c minus ax, and you would have divided the whole thing by b. It's the same. It is the same. The answer is exactly the same. You get full credit for either one of these answers. So you could do it whichever way you want. I wanted you to see both because I'm not sure how it would be on a multiple choice test. Okay, 15. We pretty much have more of the same on 15 and 16. Number 15, I'm going to isolate the x. So I first have to isolate the term that has x in it. So I'm going to subtract b from each side. And I have y minus b equals mx. And to get the x by itself, I'm going to divide everything by m. Again, you can do the whole thing at once or each one, but everything gets divided by m. So y minus b over m is equal to x. Okay, pause me, try 16, bring me back when you're ready. Okay, we're isolating the t. So first I have to isolate the PRT. So I'm going to subtract p from each side. And I have a minus p equals PRT. All of that's being multiplied on the right-hand side, so I'm going to divide by PR. And I have a minus p divided by PR. Don't try to do any canceling here. Just like earlier, you can't break through a plus or minus. Here's a negative. You can't break through that to cancel those p's. Okay, I'm sure you did well on that one. So let's go to the last two. And they look more complicated. On 17, I need to get f by itself, but it also has a fraction in it. Remember, if it has a fraction, I want to multiply by the reciprocal. The reciprocal of 5 over 9 is 9 over 5. Does this formula look familiar to anyone? That's your Celsius and Fahrenheit conversion formula. All right, and top, bottom, And I did not break through a plus or minus. That plus or minus is inside those parentheses. Those are both outside, so this is multiplied. 5/9 times this. So it's okay for us to cancel those. All right, now I have 9/5 C equals F minus 32. It's simple from here. You're just going to add the 32. And I have 9/5 C plus 32 is equal to F. You try 18. Bring me back when you're ready. Okay, on 18, you should have gotten rid of the fraction first by multiplying by 2. Don't let these subscripts fool you. This is the area, this is the formula for the area of a trapezoid. And the B's stand for the bases, and in a trapezoid, you have two bases. A trapezoid looks like this. Your bases are the ones that I've drawn on the top and the bottom, and they have to distinguish between the two, so that's why there's a B1 and a B2. It just means these are two separate variables. All right, so I multiply by 2 on each side, boom, boom, fraction's gone. So now I have 2A equals H times B1 plus B2. I think that some of you might be tempted to distribute the H here. You can, but it makes it more complicated because remember, I'm just trying to get the B1 by itself. I can go ahead and divide by that H instead of distributing. If you did distribute, it's more steps. I'll show you how you would get those in just a minute. But now I have that. And then we want the B1 by itself, so I subtract each side by B2, or B sub 2. So I have 2A over H minus B sub 2 equals B sub 1. That's the easiest way to do the problem. If you distributed the H, then this step right here, you would have had 2A equals H times B1 plus H times B2. And you're getting the B1 by itself, so then you would subtract H times B2 from each side. It's okay if you did it this way. That's why I'm showing you this. H B2 equals H B1. And then you would you're getting the B1 by itself, so you would divide by H. It doesn't look exactly like the other one did, but it's still the same answer. 2A minus H B2 over H equals B1. So that's also a correct answer. I think you'll agree that the way I did it first was easier. Okay, so that is how to solve literal equations. Remember that when I put these on D2L, sometimes I talk kind of fast, but remember you can rewind it and go at your own pace, pause it, fast forward, whatever you need to do. And also when you have finished your quiz and you're working on this, I am here to answer any questions that you need answered. You have an assignment that follows this, and I will probably give that to you tomorrow.